Hi, welcome back to Statistics 1. We're up to Lecture 4, and the topic in Lecture 4 is summary statistics. So in the last lecture, we talked about distributions and the importance of looking at distributions in histograms. In this lecture, we'll talk about the importance of summarizing all that information in just some talking points that we call summary statistics. So this lecture is divided into just two segments. First, I'll talk about measures of central tendency, and in the second segment, I'll talk about measures of variability. So this first segment, let's look at measures of central tendency. To do this, again, we're going to go wine tasting. Makes it a little bit more fun. Now remember, we had this example from the last lecture where we had 100 wine experts rate the overall quality of 8 different wines, 4 red wines, 4 white wines. And again, higher scores indicated higher quality. Now we might want to ask, well, which country had the highest overall wine rating? That was important to us as we were doing this. We wanted to see how this would come out. And just for the record, to be clear, we did this completely randomly. So my assistant, David, who is from France, and to be fair, we just said, let's generate this completely randomly so that we're not biased and so that we don't insult people around the world. A funny thing happened. David actually did this. He generated random numbers. He came back to my office with a really sad look on his face, and he said, France lost. Did we really have to do this randomly? And I said, yes, we do have to do this randomly. So let's look at the overall rankings. If we just want to look at the average, and let's just stick with the reds for now. Here are the means that we calculated from the data that we generated. So the mean for the Argentinian Malbec was 66.73. The mean for the Australian Shiraz was 81.76. The mean for the French red, I forget what the French red was 70.97. And for USA, it was a Cabernet. It was 76.38. So in this simulation, Australia won. Okay, again, this was completely random. We did not fix this. But how do we calculate the mean? And hopefully this is review to you. But again, this is supposed to be an introduction, very first course in statistics. So if you're not familiar, the way we did this is we plugged the numbers into R. But if we wanted to do this by hand, all we would have to do is take all the ratings from the 100 wine experts, just put them in a column, sum that entire column, and then divide the sum by the number of ratings. So that's the formula right here. So it's the formula for the mean or average, is just the sum of all the scores divided by the number of scores. Okay, so just sum of x over n is the mean. And these are the means for the red wines across those 4 countries. Now let's consider the white wines. So which country won with respect to the whites? Again, this was totally random. I didn't bias this, even though I had a favorite in the race, and that favorite won. So the U.S., the Rieslings from upstate New York, yeah, the cameraman's waving yay. Again, this was not biased. This was totally random. Just slightly won, right? So it just slightly beat out Australia and France for the overall average ranking. But again, let's get back to the topic of this segment. It's measures of central tendency. The mean or average is the most popular measure of central tendency. It's a very common summary statistic. I think most of you are familiar with it. So to be clear, what do I mean by a measure of central tendency? It's just a measure or a summary statistic that describes the middle point or is representative of the middle point of a distribution. So it should be representative of the distribution as a whole. Of course, we can't describe the whole distribution with one number, right? This is just what statisticians call a point estimate. But it should do a pretty good job. It should be representative. The most common examples of measures of central tendency in statistics are the mean, the median, and the mode. So the mean we saw is just sum up all the scores, divide by the number of scores. It's the mean or the average. The median is just the middle score in a distribution. So if I just lined up all of the rankings, all of the ratings on the wines from the highest ranking to the lowest ranking and just plucked out the middle ranking, say the 50th ranking out of the 100, that would be my median ranking. And the mode is easy. That's just the score that occurs most often in the distribution. And if now that you've seen histograms and know how to plot histograms, it's real easy to see. Just look for the peak of the histogram. That's the mode. That's why that one non-normal distribution that we talked about in the last lecture was called bimodal, because it had two peaks. So if there are two peaks, there are two modes. Sometimes there's more than one mode. So the mean or the average is by far the most common measure of central tendency used in statistics. It's the one we're going to rely on the most in this course. In any intro stats course, that's the one that you're going to rely on the most. So for example, the red wine ratings, another classic example is just your grade point average. If you want to know how well are you doing in school or how well are you doing across all your Coursera classes. I'm hoping that maybe you're taking more than one Coursera class. You could get your grade point average, your average across all of your courses. And there are lots of more examples of just averages or means that we can take. And those are the mean is the best when you have a normal distribution. If you don't have a normal distribution, in particular, if you have a distribution with really extreme scores, so an extreme positive skew or an extreme negative skew, then you might rather go with the median rather than the mean. And that's because those few extreme scores can really bias the mean, whereas the median, if you just line the scores up and take the middle one, those extreme scores are not going to bias the median as much as they're going to bias the mean. So we can look at the white wine ratings as an example of that, but those weren't that skewed. So we'll look at them so you won't see a big difference between the mean and median. You'll see a slight difference. Another example is a classic example right now in the US and lots of modern countries right now is household income. So household income, particularly in the US right now, particularly in Brazil right now, is really not normally distributed. So there's a real positive skew in the income distributions in the US and in other countries as well, and we'll take a look at that as well. So you'll often see reported in the news, or if you're reading stuff on the internet, you'll often hear median salary or median household income reported rather than mean salary or average household income. And that's because those distributions are skewed. So first, let's look at the wine ratings again. These are the white wine ratings because remember, these are the ones that were not normally distributed. I want to draw your attention to the Australian distribution. Remember, it was slightly positively skewed. This isn't a real strong skew. We'll see a stronger one in the income distribution in a moment. And then remember, the US distribution had this slight negative skew. So if we look at the means and the medians, the summary statistics, the measures of central tendency for these wines, you'll see that there's a slight shift in the Australian one and in the US. For Australia, the median is slightly lower than the mean because the median is less influenced by those extreme scores. The extreme scores in the Australian case were on the high end of the distribution, right? It was positively skewed. So the median is less influenced by those really high ratings. Therefore, the median is going to be slightly lower than the mean in a positively skewed distribution like the Australian white. The opposite is true in the US white wine rating distribution. So in that case, there was a slight negative skew. So those extreme negative ratings are going to have less of an influence on the median. So here, the median is going to be slightly higher than the mean. Again, because those low rankings are going to have less of an influence on the median than they do on the mean. So the median is going to be slightly higher in a negatively skewed distribution than the mean. And we see that in the rankings for the US white. Here's a more detailed graphic. Again, this one I just took off the internet. This is a histogram of household income in the United States. It shows this really extremely positively skewed distribution. Okay, here you're going to see a large difference between measures of central tendency like the mean, the median, and the mode. Okay, so if I just took the average of all of these incomes, we're going to have to average in these extremely high incomes way up here, which are, this isn't even that high. The graph actually extends way beyond that to include people like Bill Gates and Mark Zuckerberg and so on, right? If I include their salaries in the mean is really going to be inflated. In contrast, if I just take the median, the middle score, that's going to be right here. No matter whether I include Mark Zuckerberg, Bill Gates, people like that in my distribution or not, the median is still going to fall right here. It's at about $49,445. And if you look at this, the mode is actually right about here. That's way down between, like, say 15 and 20,000. Okay, so when you have this extremely skewed distribution like this, like US household income right now, over the last few years in particular, you're going to get a real difference between the mean, the median, and the mode. Because it's hard to find a measure of central tendency that's representative of the entire group, right? That's part of the problem. I'm not going to get into a political discussion about this. It's just a good example to illustrate a non-normal distribution and how measures of central tendency can really differ when you have non-normal distributions. If it was perfectly normal, then the mean and the median and the mode would be just about the same. So finally, the mode is just the peak of a histogram. It's just the score that occurs most often. So the Argentina white wine distribution, that was a real easy one to look at the peak. Remember, because it was leptokurtic. It had that really strong peak. If you look back at the graph, it was right around 70 to 72. It was also about the average because it didn't have really extreme rankings on the negative end or on the positive end. A thing about the mode is it can also be applied to nominal variables. That's not true of the mean or the median, right? But we can apply it to nominal variables. So what I did for fun is I just took these countries that we've been playing with, the US, France, Argentina, Australia, and I just said, well, in the last year, what are the most common or what are the modal baby names? These really surprised me. I don't know if my source is accurate. But in the US, the most common female baby name in the last year is Sophia. Most common male name, James. In France, it's Emma and Nathan. In Argentina, it's Sophia and Juan. And in Australia, it's Charlotte and Oliver. Those are the modal baby names. They're the ones that occur most often. It's only the mode that we can apply to nominal variables. We can't apply the average, for example, to nominal variables or the median to nominal variables. So to sum up this segment, we're talking about summary statistics. Some of the most common summary statistics are measures of central tendency. By far the most common is the mean or average, but we might want to use the median, particularly in cases where we have skewed distributions with really extreme outliers. In some cases, we might want to just look at the mode, which is the score that occurs most often.